Okay, people did pretty well as a group. Okay, so there's some errors, but I've seen evidence that you're learning something from open that. Okay. Whatever you're doing, it appears to be getting better. So it's very good. Okay, so you find f of g of x, these two functions. So f of x is 3x minus 4. So f of g of x is 3g of x minus 4. Then if you skip this step and got it right, then I prefer that you continue to reinforce what you're doing by writing out this step. I'm not requiring it. Advising you, you remember this longer and better, be less likely to trip over it when you see it in a later course. If you keep reinforcing the form of the substitution. Okay, anyhow, g of x is 7 over x plus 2. So that's 3 times 7 over x plus 2 minus 4. Okay, you want to multiply through by the 3. That's 21 over x plus 6, because 3 times 7 is 21. 2 over x. 3 times 2 is 6. You use the distributive law here, right? Be aware that you're using the distributive law because later you're going to be in a complicated situation where you might not think to use the distributive law. Keep reinforcing the rules. Okay, so you got 6 minus 4, and that's going to be 21 over x minus 2. We're going to see all the steps. It doesn't take long to write them down. But if I'm seeing the right answer, more or less you can follow the right steps. On a test, it's very important to do all the steps because you write down just an answer and you made a stupid little error like you see me make all the time, you're not getting any credit. I can't see where the error occurred. I can't give you partial credit. Okay. Okay, so that's your f of g of x. Now, here's how you want to write this out. If f of g of x equals square root of x squared minus 1, then there are a couple of ways this can be written as a non-trivial composite. Okay. Perhaps f of x is the square root of x. And g of x is x squared minus 4. Because you plug in g of x for x, you get f of g of x. Then replace this x by x squared minus 4, and there you have it. Okay. Now you could also let f of x equal the square root of x minus 4, and g of x equals x squared. That works just as well because if you replace x by g of x, you're going to get the x squared minus 4 under the radical. Okay. I don't think anybody saw it like this, but it's equally valid to this. Could go either way. All right. Now let's get to this bacteria concentration. Okay. Okay. We want to find P is a function of T, not C, okay? Now it is a function of C, but now we want to write it as a composite. So write P of C of T. So it's do the composite. Okay. P of C equals this, C of T equals this, so we can replace C by this expression. But we can write it as 1 minus over 2 minus C of T. Which is 1 over 1 minus 102 to the T. Okay. And that is composite. We've replaced C here by now C of T. We replace this C by the expression C of T, and we get this. And that's it. Okay. Now, oh, my function didn't make any sense. We're going to go with it anyway. Okay. That probably changed it here in a bit. For example, if T equals 10, one point oh two to T, I think is around 1.28 or 1.29. That was a question mark for that. Well, that would give you a probability if you plug the numbers in and do the calculations of 1.4. Well, probability of 1 means you're getting sick. The probabilities can't be bigger than 1. So there's something seriously wrong with my numbers. Okay. As this number down here is going to approach 0, this is going to approach infinity. You don't necessarily understand that. So what in the world was I thinking? Anyhow, I'm not going to try to get a realistic function there. So you understand that what you get here is what you could get alternatively if you don't understand the composite. Don't see it as a composite. But I think you pretty much understand composites fairly well, but in a situation like this, it might not be as clear. Okay, so what you have is T gives you C of T, which then gives you P. Okay, so we could say Okay. That's probably 1.5. So we never used a composite here, but we use the same idea. This is the way composites work. You start with your variable, you get one function in a chain, and then you plug that value into another function. And hopefully you've seen how that works. So in this case, if I know t, I can find the value of c from this, which I can then plug in here. Okay. So I said, to get the probability after 10 days, you would just calculate this for t equals 10 and plug the result in here, and you get an answer. Okay. It's a little more compact if you find p as a function of t by plugging the expression c of t in or just c. And you get a composite function. Right there's your concentration. Right here is the probability of that concentration. Okay. And now you can evaluate that function for all kinds of different values. You go to Excel, if you know how to put that thing into Excel and do a spreadsheet that tells you the probability after each day. Now, the probability function I gave you doesn't make sense. So I'll come up with one that does make sense. Play around with it right now. Okay. I wasn't careful enough when I made up that function, but you get the idea. This affects that, that affects something else. Okay. So this number affects this function, and the value of this function goes into another function. That's it. And I think you should have gotten that sense pretty well out of the open math assignment. People did fairly well on the assignment. I think some people didn't do it, but most people did. I haven't yet. I had you upload your work for 5 points at the end, so your scores are probably going to be 5 points higher if you did that. Okay. At this point, I'm just going to give you credit for whether the work looks good or not, but then I'll give you feedback on the front. Okay, next time, you know, document it a little better, or next time, show me some more steps. I couldn't tell you how you did some of these problems. Maybe it even looks like something you copied from an AI. Okay. I'm going to want a little more than that. I'm going to want a little more than AI. Give me some thoughts on how you thought through it. Okay. So we're going to work on that. We're going to get to that point because I think you're going to learn real well by doing that. And then you're going to have a knowledge of pre-calculus. It's very much your benefit in later courses. Okay. And if you don't go beyond pre-calculus, in your curriculum, you're going to see stuff related to it. There's a good chance you're going to see stuff related to it, and you're going to understand it much, much better. Okay. I have to say, this is the task you should have mastered 3 weeks ago. Okay. Now, everybody did a really good job the first couple of days, but you've let it slip away from you in some cases. Some of you say doing very well. So all I'm saying is, we're going to have a test next week. You're going to have to do it. I said a little more than that, but that's all we really need to say about it. Well, I'm going to do what I asked. Here's the rectangle. Halfway from the top to the bottom, halfway from there to the bottom, halfway from there to the bottom, halfway from there to the bottom. Those are the horizontal lines I need for the square function. If you're not drawing these, think most of you just have not drawn these enough. You need practice. It's not hard. You just have to practice until you know it. Okay. Everybody can do that. I think everybody will. It's not an impossible task. Okay, then for the vertical lines, well, we would go halfway between the edge and the center, halfway between there and the center. Got a little too close down here because I can't draw a straight line, but still have something that can reasonably approximate the graph. Okay, so there it is. Now, this HK, in my case, this point would be 5, 5. But I'm going to make it 5, 9. I don't have more than last one. Okay, so that's a 0.59. This is 4 by 4. So the dimensions here are 4 by 4. It doesn't hurt to write that in. Might be helpful to somebody to remind yourself of the dimensions of the rectangle. And I might give it to you. I might, a rectangle, next time I might ask you to do a 16 by 8 rectangle and figure out what construction line could be. The picture would be the same, but you'd have 16 here and you'd have 8 here, and your numbers would be different on your construction lines. Your red dot would still be where it is, okay? Well, let's just make sure we can do it from the 4 by 4, because if you understand the numbers in the coordinate plane and the way they relate to your location in the coordinate plane, then it's very easy to do it no matter what the dimensions of the rectangle are, okay? So, well, easy enough. This is 4. From here to here is 2. The x coordinate is 5. So this is the line x equals 5. What's this line? Well, it's 2 units to the right of x equals 5, which would be x equals 7. And this is 2 units to the left, so that's x equals 3. Now it's 4 units from here to here, and this is in the middle. So we can check that, okay? You want to think it through that way, check your stuff. In case you write something down that you think's right, and all of a sudden you think about it and say, oh, that was ridiculous, let me fix it, okay? Now, this line is y equals 9. It's 4 units from here to here. Well, 4 minus 13, so this is y equals 13. This line is halfway between here and here, meaning it's half the horizontal line halfway between the line y equals 9 and the line y equals 13. What's halfway between 9 and 13? It's 11. Another way of saying it is, it's 4 units from here to here. This is halfway from here to here, so it's 2 units from here to here. And you add 2 to 9, you get 11. Either way, you check it. Since this point is that this horizontal line is in the middle between this one and this number better be in the middle between this one and this one, which means if you add these numbers and divide them 2, you should get this. Alternatively, it's 2 from here to here, it's 2 from here to here, it's equal. Okay? Look at it in every way you can. Okay? Now, this line was halfway from here to here, so it's a y equals 10. And then you have y equals, we write 9.5 or 9.5. Then over here, you have y equals 9.25. Well, we label our axis. Again, this line's halfway between these. Width is 4, this is 2, this is 1. So we have a line 1 unit to the right of x equals 5, which means it's at x equals 6. Similarly, we can reason out that this is at x equals 4. And then play with these down here, x equals Make myself read it right. Okay, now we've got the coordinates. Now we construct the squaring function. Okay, that took way too long to do the first steps, so I'm going to do these steps for you, but I think everybody knows how to do them. Not everybody has a graph that you can conveniently do this on because you don't always have it. It's not everybody has the lines in the right place. So look at my graph if you have to. Start upper left, right one, down two. Right one, down two. Oh, there it is, right one, down two. Okay. You have that 9.25 line in there, not to put a point on, so you can skip it and you end up with a red dot. Looking at a cross, I've never seen the red dot was there. Okay, anyhow, then you go right one up two, right one up two, right one up two, and you got these points, and now you can see it. Okay. Now there it is. If you need to use my numbers. Okay. If you can answer the rest of these, hopefully with your own numbers. But if you need my numbers. All right. Now. F of x equals x squared. Then just in symbols, if f of x is x squared, what's f of x minus h? Write it down. You know, don't put the question mark there, put the expression, and then the expression for f of x minus h plus k. As I said, there's something maybe about the context here that making this seem different than what most of you just did successfully on the quiz. Okay, which was form a composite. This is just a composite. If f of x equals x squared, f of x minus h is what you get when you replace x by x minus h, right? And what's that? Well, you got x minus h squared. Many of you wrote x squared minus h, but if you replace x by x minus h, since x is squared, the whole line x minus h is squared, right? So make sure you have that straight. Okay. And y'all children did, most of you do pretty well with making composites. This is just another example. Okay. Now, having done that, f of x minus h plus k. Well, f of x minus h is still x minus h quantity squared, and then we have plus k. That's all there is to it. Okay. Now, some of you use the h and k numbers I told you to use. Okay. Now, if you didn't have the graph, you're going to use h equals 5 and k equals 9. And that's what I'm going to do. But if you have a good graph for your own numbers, h and k, use them. In other words, plug in your number for h and plug in your number for k and see what you get. So do that kind of quickly. I'm not going to give you a whole lot of time for that, but I think you can do it quickly. Okay, so in my case, h is 5. That's not really my case. In this case, H is 5 and K is 9. So this would be X minus 5 quantity squared. And this would be X minus 5 quantity squared plus 9. All right. Now, I want you to make a table for the coordinates of these points. Okay. And I'm going to ask you, I'm going to ask you to make two tables. And okay. There, but then you go there. Oh yeah, we're going to call this function g of x. So ultimately g of x, in my case, is the x minus 5 squared plus 9. Okay. Now we want to do this table from the graph. But then we're going to do another table that I don't want you to do yet. But leave yourself room to write them side by side. Okay, so we want the two tables side by side. Okay, now it should be very clear that the points on my graph, the x values of 3, 4, 4.5, 5, 5.5, 6, and 7. This line, this line, this line, this line, they're all labeled. So you have 3, 4, 5, 5.5, 6, 7. And the y values are what? Well, for x equals 3 and for x equals 7, you're on the y equals 13 lines. You got 13 here and you've got 13 here. Or x equals 6 and for x equals 4. The x equals 4 is here, the x equals 6 is here. That's the line y equals 10. So we have 10, 10. Now, if you skipped this point, you don't want to skip the fourth point. But if everything else is right, or most of it's right, you're doing okay. But you really want to be a little more focused, okay? Want to get all the points. So what's this point? Well, x is 4.5 on this line. Well, here it is 4.5, and y is 9.5. Sorry, wait a minute. Whoa, 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 whoa. Something's terribly wrong here. Y is 9.25 on that one. Okay. Yeah. Okay. And then I drew another line here. Okay, to skip. Okay, but it is 9.25. The 9.5 is here. Doesn't have a point over that. The 9.25 corresponds to x equals 4.5 to 5.5. So that's 9.25, 9.25. And when x equals 5, y equals 5. That's the point we started with. Now, if you got the point for your own graph, if you did the graph, well, this is what I'm going to ask you to do. I'm going to ask you to do a lot more stuff that you do in the chapter. Okay. But it's in the context of these graphs. And it's not tangible to you unless you have these graphs. And we're trying to make this tangible. Now, over here, x is going to have the same values: 3, 4, 4.5, 5, 5.5, 6, 7. Okay. Now we calculate, we plug these numbers in to this function. Okay, or to the function you have. So for example, if I plug in 3, first of all, g of x is x minus 5 squared plus 9. G of 3 is 3 minus 5 squared plus 9, which is negative 2 squared plus 9, which is 4 plus 9, which is 13. So we're going to put 13 here. Now we notice that it agrees with this 13, doesn't it? Okay. And if you've done it right and you do the arithmetic right, you're going to agree with the table you've got. Now, if you're messed up on your table one way or another, if you don't have a good table, then do what I've done here for my function. These points. You got your own, do it for your own, because you learn better if you do it for your own. Okay, now we don't have time for everybody to do all the arithmetic. But you can see, if we plug 4 into this equation, what's x minus 4? Or, what's 4 minus 5? It's negative 1. You square that, you get 1, and you add 9, and you get 10. That should be obvious, okay? Although you really overrely on the calculator, well, I think on the test next week, I might not allow calculators at all. Okay, make sure you can do arithmetic. Okay, takes you a while. It takes you a while. You need to practice. Okay, and then we plug in 4.5. 4.5 minus 5 is negative a half. Square a half, you get 1/4. Okay, add that to 9, you get 9 1/4, which is 9.25. And then the rest of them come out the same. If you plug in 6, you get 6 minus 1. Square that, you get 1, just like you got 1 when you plugged in 4, because 4 minus 5 is negative 1 squared. You get 1. Okay? There's a pattern here that you see if you do the arithmetic yourself. If you put it into a calculator, you're not going to see the symmetry of the pattern, and there are things you're going to miss. Okay? So I strongly recommend you do this exercise on your own or make up some different numbers for each and okay? Now, take a lesson. Y'all do much better at, the homework is looking pretty good, okay? I think you're starting to learn better from the open math. So I think you're doing pretty well, but yeah, we want to keep progressing in the whole learning process. The same point I want to make today is it's a lot more that would have been helpful to you if we could have done it. But we didn't get to do it because you didn't know how to draw the graphs. Some of you didn't know how to draw the graphs. Okay? At least a couple of you drew them relatively quickly. But if you can't draw these graphs, subdivide them and label all the construction lines in about a minute or two, you don't know. Don't have a tangible grasp of what's going on. Now, there's some rules that the open math is really easy. Okay. Okay, note that this graph graph is shifted 5 units horizontally, 10 units vertically from the basic toolkit squaring function. Okay. That means you come 5 units over here and 9 units down, you got the basic squaring function, which would be kind of down here. You move it over 5 units and up 9 units, and you've got this. This verifies it. It verifies that this form of the function, the x minus h squared plus k thing, shifts the graph. But h units horizontally and k units vertically. Okay, so I'm going to say that statement. Cube x equals f of x minus h quantity squared plus k shifts the graph 5 units horizontally and 9 units vertically. Now there's another thing you can do to it. You can multiply the f of x minus h by a number, and that vertically stretches the graph. Doesn't shift it up, it stretches it out. Keeps the vertex read out where it is and stretches it out before you move it over and move it up. We wanted to talk about that, but we had to get a tangible grasp on this thing that you are certainly going to be asked for the test next week, along with a bunch of other stuff. Okay, and it might be the exponential function, it might be the square, or the reciprocal function. It might even be the reciprocal square function. I'm going to show you how to construct briefly next time. Very easy. Okay, just one of those over one up 2 rows over 1 down 1 on the square function. We'll see how that works. Okay. All right. So, stay on it. Y'all making some progress. Okay. Tell you more about what's likely to be on the test next time. I'll have a sample test for you. So look out over the weekend.